Hello, everybody. Today we're gonna be designing some stuff for the for my home assistant, or for my smart home that I'm making. Um, we're gonna be using this ST7789V TFT LCD board. I have one of these because I thought it was kind of cool at the time to just have, but I never really played around with it. So we're going to be using this as our base, and we're going to be attaching a bunch of sensors to it. Um, and we're going to be using Easy EDA, um, brought to you by JLC PCB. And then we're going to just go with it, I guess. My music. Let's throw on some lo-fi from Stream Beats. And so, yeah, let's start it off. So I already pulled up the board because that's usually wastes a lot of time just finding the appropriate board to use. So we're gonna have a whole bunch of sensors, some of which I already have. So we're gonna be using the SHT31 sensor. Now, this is going to be using, this is a temperature and humidity sensor. Let's see if we can bring that up in Control Fine. What is it? SHT? Yeah, SHT 3X. So the X means anything after that. It could be 1. It's using our Adafruit has a thing that we used last time on our board, on our home board, but I realized that it's like $2 worth in parts. So I'm just gonna put it on my board as is, and then I figured out with the data sheet and everything how to use it. So we're gonna be using this. We're gonna be using basically, the sensor, this sensor right here, that chip right in the front, or right there, is the one we're gonna be using. And that's right there, I think. Yeah, right there. And that's like $2. And they're charging $13.95 for it. So I'm like, no, thank you very much. We're okay with that. We're okay with just paying the $2 for this chip, plus the $3 shipping from China. But I can get a whole bunch of these for the low price of what? Even if I was just to order one, two plus $4 for shipping, it's about $6. That's still under half the price of what you can do it with here. So if you have the knowledge, the education, that's why they charge so much. It's not the fact that, the parts are, stupid easy to come by. It's the fact that it's the knowledge that people use to implement those parts. Which is why, plumbers, they charge so much. It's because it's not for the time, it's for the time they spent at school. So when you put this on your board, we need to, I need to find the schematic for the board. Hopefully data sheet? Please tell me there's a data sheet here. Nope. Nope. Oh, wait, did I throw it in my Discord? Because I knew I was going to need it later. Yes, I did. Open original. Yes, that's fine. Here we go. So the SDA and the SCL are 21 and 22. So now with this, the SDA and the SCL need a pull-up. So we're going to use these 10K resistors, which is kind of what you see if you looked at the Adafruit one. Nope. Yeah. Oh, wait. Nope. That's the other sensor we're using. Nope. That's the other sensor we're using. Nope. Nope. That's not the sensor we're using. Aw, man. ESP home ISO. So, yeah. We're using the this one. If you look at it right there, it's just a bunch of resistors here. Oh, if I can get close. Can I get close? Yes, I can. So this is just resistors. And then this is supposed to be for... I think... No. That's a capacitor there. That's a capacitor there. I think they put a... No, they didn't. Just a bunch of capacitors to smooth out the V in. Which should be actually supposed to be a 3.3 volt regulator here. So we don't fry it, but... That's fine. So we're going to attach that to 3.3. VSS needs to attach... R needs to attach to ground, and VSS is the ground. VDD is the positive terminal. And then... Where's the... Cool. So we're going to throw that there. Quiet these guys down. SDA is 21. SCL is 22. There we go. We got our first one done. Got our first sensor in. And... Okay, so save this. Our next thing... Wait, where's chat now? There we go. Alright, so the next thing is going to be... any one of these is going to be good for any pin. Our next one's going to be... Nope, we're not grabbing... We're grabbing something from one of our previous projects. ESP main home board. Let's grab it from here. We're grabbing that. There we go. Yep, nope. We're grabbing our DHT11 sensor, a digital temperature and humidity sensor. It's going to be a backup just in case this one, the SHT, doesn't work. We're just going to do that real quick. VDD 3.3, ground to ground, and then I just need any pin for the data pin, and that's fine. And we'll save that. We got our next part on. So what's our next? Okay, so our next thing we're gonna do is we're gonna grab this CSS 811 because nope, CSS 811 control find V. Yeah, we're gonna try and do some CO2 and volatile organic compound sensing, just for, you know, seeing if the air quality. This is like air quality sensor, so I'm gonna throw this on. Now I got, well, that's the chip internals, whatnot. Let's try and find it. Library. Assembly. Yep. Because this is board we're actually going to assemble. VDD. We're going to attach to 3.3 volts. Is an active low and is pulled up by VDD by default. Is optional, but pull up and or coupling with it may be necessary to avoid. The pin will be pulled low during reset. So there should be a schematic here on this of how we're supposed to do it. There we go. And now I'm going to be All right.
I'm not quite sure how to help you with that.
Of course you don't. So, oh, this is part of the host system. Wait, recommended application circuit. Okay, so that should be together. Ground. Where's the ground on this? Not connect exposure pad. So where's the ground? Okay, so I see everything but the ground. Oh, exposure pad. Okay, so is ground. They actually put that in so it works. Cool. All right. So exposure pad connect to ground. That's what you need. Okay. There we go. All right. So that's fine. All right. I'm surprised they just didn't make the NC no connect pin, just that ground. That was kind of dumb on their part. All right, so do I need a pull up on this? Where was that schematic we were using to grab everything? There it is. Okay, so I need 4K7 resistors, I'm assuming. So like open link, because these guys have, it's really confusing because these guys have, I think, a 3.3 volt regulator in here. And then I don't know what these are. And I don't know what this is. But it doesn't look like it's part of... I wish they had a Adafruit. Let's see if Adafruit has a schematic for this part, and if they do, I can just datasheet. Same datasheet, same datasheet. Do you have a download PDF? Show me, because I really just kind of want to steal your schematic. Here we go. Ah, they put, okay, so they put so they put diodes there instead. They put 10K for pull-ups to 3.3 volts. And I know it's not clear to you because it's not clear to me either. 10K to ground dress. Okay, so I need to find my 10K resistors. Oh, wait, I'm gonna be printing... Nope, we're not using these ones. We're using... SMD. We're using... Because I'm gonna be manufacturing this board, I'm gonna be using the 10... Nope. The 10K resistors right there. For this. Copy that. Because I might as well just, instead of have everything just, yeah, instead of having everything just, and this goes to ground. Yeah, instead of having everything just kind of like mess. Oh, what was I gonna say? Yeah, instead of just ordering the board where I have to add pieces, I'm just gonna manufacture it where the resistors are like 10 cents, not even, they're like a penny. So I might as well just put them on the board and have them manufactured if I'm gonna have this manufactured anyways, because the part is less. Alright. How do they do this now? So I'm just basically going to be copying what they have. The wake function, it has a pull up for another 10. And I'm actually kind of glad that Adafruit does this, because then I can just do what they do. I don't have to reinvent the wheel. W. This goes to VDD. And then each one of these has a wake. Where's the wake? Wake's gonna have one of these. And then reset's gonna have one of these. That doesn't seem right. Right, it's supposed to be pulled down. No, it looks like... I wonder if they do this for the other sensor too, because I really... Oh, wait, no. I want to finish this one first. Shit, where'd it go? It's near the bottom, I know that. Alright. So... Sense volt. And these just go to... I squared C pull-ups. Gate. No. I'm already pulling up the SCA and the SLC right here with these resistors, so I don't need to do that again. This one is what? SCL. And that's fine. SDA. Oh. Right there. And SDA right there. Okay, so I think this one's done. And yeah, no. That's all she wrote. Set default to wake low, woken up. Used to cut pin. Wait, what? Set default wake to low. Wake pin is assessed before the transition. Let's see what we can. Is an active low input and should be held. Power is not an issue, and wake can be connected to ground if a spare GPIO is not available. Wake needs to be on a low? Wait, Adafruit, what do you got? What do you got for me here? I want to follow that trace back. Oh, you're right there. Okay, so wait, no. Just grab it from here. There was a reset pin. Cut to use pin. Oh. So this... Nope. Okay, cut to use pin. Okay, so this needs to be on the exposed pad, which goes up to ground. Okay, so that's fine. That's what I wanted. Okay. Int. What's int do? INT. NINT. In an active low, optional position. Optional output. It is considered low to a threshold value has been triggered. Alright, so we're going to throw this onto another pin. Because I'm pretty sure it does something important. So that's fine. What the f is this pin? Nope. We're good here, we're good here. SEL. Okay, so wait. That's good, that's good, that's good, that's good. That's good, that's good. And so I think we're pretty good. So the next thing would be that that sensor's done. Okay, so that sensor's done, that sensor's done, that sensor's done. I'm gonna put a I told myself I wouldn't forget this. Nope. We're going to put a 4-pin pad out for 3.3 ground SCA and SLA SDA whatever yeah SDA SCL SDA SCL out, and this is for if I want to. I was thinking of maybe throwing on a one of these other sensors on here. Let's see if we can control 0 that. Like one of these particle sensors that are worth like $50. And I don't want to spend that money right now, but in the future, maybe later down the road, I can add it onto this thing. The other thing I wanted to do is we're going to throw on some buttons. Library. Button. And we're going to do an assembled one. Nope. You know what? This is... Oh, it's not rated for SMT. Angle button. What button? Nope. Nope, it doesn't look like we have buttons here, so... We're going to do 1, 2, 3, 4 buttons. We're going to grab them from the main board. These are the only things we're going to have to solder on. Two, 3, 4. We're just going to go down the line. Ooh. I just... There. 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 Okay, so we're getting close. finishing up now. Exposed pads, which should be the ground. I don't like how they do that. Like, you can't fix this either unless you, like, physically go to this thing. And I'm like, yeah. But even then, it kind of sucks. I don't like how they draw diagonals. And then VDD. There. Alright, so all these buttons are active now, so we're just going to throw in there. A button here. A button here. And a button here. Alright, so we got 4 buttons for like a keypad or something. We got 1 sensor, 2 sensors, 3 sensors, possible 4th add-on sensor, so we don't have to do that. What else is there? Not too much. So, I think... yeah, no, this is it. This is all I wanted out of this sensor. I might throw in... we're gonna also copy the 5-volt regulator over because, you know, might be using 12 volts instead of 5 volts for our system. I am not sure yet, but I'd rather have like this, again, 2-cent part versus... oh, we didn't have an in yet. We don't have a power in yet. That's actually something we gotta look at. Nope. Nope. If I closed it too soon, I accidentally had the... come on. Copy that. There we go. Save it. Okay, so we got power coming in. Ground. Ground goes to ground. 5 volts out. Cool. So this is it. Save it. And I think this is what we're gonna be going for, because I think that the ESP32 is doing a lot right now. It's gonna have a display on it. It's gonna have a temperature and humidity sensor, 2 temperature and humidity sensors just in case one fails, a volatile CO2 scanner, and a and another sensor. Oh man, volatile, whatever, and an O2 sensor. So that's good. So we're gonna keep that there. We're gonna convert this to a schematic. Nope, keep going. And apply. So wait, I gotta check the... nope, not that website. We're gonna go for... okay, so it's positioned this way. So we're gonna position it that way. There. Do that on this side. That's power in. We're going to rotate it up so it's on top. Actually, I'm going to throw this over here. Throw this up here. Throw this over here. Actually, I might turn this way. There. So the power regulation... Ooh, the power regulation is going to throw off some heat. Heat rises. I want these things below. Power regulation up here. That one goes there. One, 2, 4, 3. Evenly space them and pull them all up. And we're just going to slap these wherever, to be honest. This is not like the highest power draw thing. This is supposed to be for something. It's going to run minimal power. Yeah, this is just going to be something small, something not big. Let me guess. The main board's there. Alright. So 1 and 7 are for that. Sensor. 1. 7 are for you. Alright, right there. That's fine. So what I want to do is have like a wind tunnel here. Have it open so it can detect stuff, but not have dust land on it. So this is 3, 5. Alright, which ones do I need? 2 and 3 for the U one. 2 and 3 for that one. So 4 goes here. I'm assuming 8 goes somewhere over there. And are we done? So the buttons use 4, 5, 6, and 8. 4, 5, 6, and 8. Okay. For saving space, I really just kind of want to... I really want to cram these down here, but I know if I do that, it's going to be a pain. You know what? No, this is all going to get soldered on, so I don't give a And this board will just sit right on top of it. It's fine. Yeah, there we go. I do kind of want those pictures in there, so I will give it a little bit of room. And you can just sit nicely right there and still have that open breezeway. Where do I want these to go? Oh, for fuck's sake. Nope. One at a time then, eh? Alright, there. Yeah, this is gonna try and be open, and then I got my buttons there. And it's fine if these overlap a little bit. There we go. A little less of an overlap. So, okay, so we got a nice breezeway for these sensors to pick up whatever. And I think we're good there. No, I should actually turn this one this way, put it right next to the edge, save it. And now we're just going to auto route this because that's a good feature. Well, oh, no, nope, stop the router. Auto route, auto route. Change design specifications. We want to do at least 0.5. Settings. Run. $95, $96, $95, $96. And you can see it's doing like micro changes in where things go. Oh, 4 failed. How the did 4 fail? Okay, so we're gonna try route, auto route again. We're gonna change this to PCB. No. Trace with calculator. We're gonna use our favorite trace with calculator for PCB. We're gonna use 1. This isn't gonna even be an amp of power. So let's change mil to that. So we're looking at about 0.3. That's fine. 0.3. Accept. Run. 100. There we go. All right, and we're good. We just created design and we're gonna order this. Hopefully. All right, let's save it. Yes, override. They've been having some of that difficulty figuring that out. Check DRC. Nope, we're good. And there we go. Yeah, no. We're just gonna generate this. We're gonna create the thing and go for it. Order parts. PCB, SMT. Yes, okay to continue. It's gonna activate for my account. And we're gonna do that off screen. Ah! I didn't want you to be a thing. What? Why? Remember me. I am not a robot. Sign in. And we got to do it again because it forgot that I wanted to do that. Okay. Next. Assembly quote. Here we go. Next. Give me a quote. Give me a quote. Next. $41 for... Holy cow. For all these parts. Wait, I don't want a J1 part. That. No, I don't want to spend 55 cents on that. Thank you. Okay. I might need to go over this, but $41, give or take a few cents. is what... Wait, what? You don't have that part? I specifically thought... Okay. Well, anywho. Oh, it's $12 for all of them. Okay. We might be having trouble figuring out this one. What's going on here? The whole reason I wanted to build this thing was for that one part. Library. Control V. Well, I'm gonna talk with these guys and try and figure it out. I know it's gonna be $7 extra times 5 boards, 35. I know it's gonna be super expensive, but we're gonna be doing that. So add another $35, so about $70 for these sensors. And there's gonna be 5 of them. So I think we came out pretty good. Anyways, so I have to order these, figure out what's wrong with this, but I'll get that back to you on a later date. And, well, have a wonderful afternoon, evening, night, guys. And I'm going to be signing off now. Bye.